All right, so here's going to be the homework video for 10.1, Rules of Exponents and Logarithms. Sorry if my voice is a little muffled. I'm at school right now, so I've got my mask on. Number one, first thing, I know that I can move that 1/3 value and that 2 in front of the natural log to become the exponent of what's inside the natural log. Also, because of the addition, I can make this into, a multiplication. And then 27 to the 1/3 is 3, 2 squared is 4. I end up with natural log of 12. Next one, really going to follow the exact same process. The 1/2 becomes the exponent of 16, 2 becomes the exponent of 10, and then because this is subtraction, I can turn my problem into division. 16 to the 1/2 is the square root of 16, so that's 4. 10 squared we all know is 100. Then I can reduce to 1/25. Now, 1/25 is the same as 5 to the negative second. I can move that negative 2 in front, and then the logarithm, when the base and what we're taking logarithm of are equal, we know it's just 1, so my final answer is -2. Number 5, 13 times 5 to the x power. Our goal should always be to try and get the value that's the exponential function alone, so I'll divide both sides by 13, and that gets me 5x equals 125. Well, 125 is the same as 5 cubed, and now since my bases are equal, I know x equals 3. Number 7, again, for this one, we really don't have much choice but to graph. So I put what was on the left in y sub 1 and what was on the right in y sub 2. If there hadn't been the +1, I might have been able to do a little bit more work, but with that +1, there's not much I can do. And so I asked the calculator for their intersection, and it's 0.103. Number 9, I can rewrite using my conversion that I would have log base e of -3 equals x. Log base e we call natural log. And since we can't have a negative number inside a logarithm, this value does not exist. Number 11, I'm going to rewrite using my conversion, so I end up with √3 to the x equals 1/9. √3 I know is 3 to the 1/2. 1/9 can be 1/3 squared, or in other words, 3 to the negative second. And now since the bases are same, I can set the exponents equal and solve. For number 13, I'm going to use a few of my properties that addition leads to multiplication. So by the time I multiply these values together, I get 3x squared minus 2x minus 1 equals 3. I can use my conversion, 4 cubed equals 3x squared minus 2x minus 1, multiply out 4 cubed, get my quadratic set equal to 0, factor, and come up with my 2 potential answers. If I check, -13/3 would make this first logarithm have a negative value inside it, so my only answer is 5. 15, we're going to follow a very similar process. I'm going to move my 1/2 to become the exponent of x. I'm going to change this subtraction of logarithms into division. If I distribute this 2, it would then become the exponent of the 2 and the 5, and I know addition becomes multiplication. I can multiply everything out, reduce my fraction, and my fraction is going to reduce to 1/5. And since it's x to the 1/2, I know that I can square both sides to solve for x. 17, I'm going to divide both sides by 17. I know that 10 to the x equals 3 can be written as the common log, or log base 10 of 3, which I can stop there, or I can ask my calculator to convert the value. All right, let me see if I can find the rest of the problems. All right, well, it looks like for some reason I've not done the rest of the problems. I apologize for that. We'll take a look at what's remaining when we get to class in the coming days. Let me just double check it's not at the bottom. Oh, there it is. Okay, my mistake. So, number 19, I'm going to rewrite 8 as what I know to be 2 cubed. So we're going to fix this mistake as we go. Since the bases are the same, I can set the exponents equal. And so that's going to get me 3x minus 1 equals 3 times 1 minus x. I'll distribute start combining like terms. So I'll add 1 to both sides, add 3x to both sides, and 6x will equal 4. And if I divide by 6, x will equal 2/3. All right, multiple choice number 2. I'm going to rewrite, changing my multiplication into addition, rewriting my square root as the 1/2 power. I'm going to take those two exponents and move them to the front of each logarithm. And then in the problem, they tell me the value of log base A, they tell me the value of log base B, of B, substitute those in, simplify and solve. And finally, multiple choice 3. They give us f of x is log base 2 of x. They ask for f of 2 of x, so I replace x with 2 over x. Division can be rewritten as subtraction. Log base 2 of 2 would be 1. So from there, I can make a substitution where I know that f of 2 of x, 2 over x, pardon me, would be 1 minus log base 2 of x plus log base 2 of x. Those would cancel each other out, and my answer would be 1, choice B. Again, I hope this helps. If it has not helped, please feel free to ask questions in class.